Thank you very much for having us here. We are from faraway land of Minnesota. I'm Elena Machkasova. I teach at the University of Minnesota Morris, teach computer science.
I'm Ryan McArthur. I'm a junior CSI student at the University of Minnesota Morris.
I'm Thomas Hagen. I'm also a junior CSI student.
And we'll be sharing with you some super fun that we had with first-class shapes in Quil this summer. That was Thomas's and Ryan's summer project. Okay, so what we'll be talking about today is who we are and why we would like to work on this topic, how it fits with other things that we're doing. And then we'll talk about functional MVC in Quil and how first-class objects fit into that, first-class shapes, and then talk about some ideas and examples that helped us develop this project, and go into details of implementation, and then we'll talk about a very long list of future work that we have. Okay, so this is what our campus looks like usually in November. It doesn't look like this, or at least wasn't looking like this when we left, and we're not complaining. It's a small campus of University of Minnesota. It's a liberal arts campus, undergraduate only, and it's not located anywhere close to Minneapolis or St. Paul. It's about 3 hours drive, depending on who's driving. And we've been working on various things related to making Clojure more beginner-friendly, and by beginners we mean absolute beginners, so people with no programming experience whatsoever. So a few things need to happen for this. We want to make sure that beginners can understand Clojure without knowing any programming, but in particular without knowing Java, and that obviously affects how error messages would work. So we've been looking into that a little bit, and I talked about this at Clojure West. We also would like to have a few fun and exciting libraries for beginners that would allow them to explore functional programming, recursion, abstraction concepts that we would like them to learn and have fun at the same time. One of the items on our to-do list / wish list is integrating with a beginner-friendly IDE. Cursive may be a thing, we don't know, but right now that is also something that we're working on. This particular talk fits into this in the sense that we'll be talking about the second part. So some material that beginners can work on that will help them learn concepts. And that was a summer project that Thomas and Ryan were working on for about 6 or 8 weeks, depending on how you count. This project was inspired by a very similar library in the Racket programming language. So Racket is a Lisp. It's a descendant from Scheme, and we use Racket in our introductory classes now. So for students who don't have any programming background. And one of the really nice features of Racket is its universe package that implements functional MVC. So it has the separation between model, view, and control, and it has functional implementation of MVC. So there is a world state, and it contains all of the things that are changing in the program. And then you provide functions to modify that state either on a clock tick or when a certain event occurs. And then you also have functions that take that world state and make an image out of it. So there is a complete separation in this program and in students' minds from the model, which is the contents of what's happening, representation of what's happening, and the view, which is the image of what's happening, visual representation. And Racket also has first-class shapes. So you can define a circle, a blue circle of radius 5, and you can use it in your program as an object, and you can store it in a variable, return it from a function, put it in a list. So you can do anything with it that you can do with a number. And you can have various shapes. You can also have user-imported images there, so JPEGs and other formats. And you can use this to create games or art or various interactive programs. And there is a variety of functions that can be used to combine these shapes into more complex shapes. And then, again, treat them as one thing. So you can combine them, create a picture of a car, and work with it in your program however you want. And when you need to put it on the canvas, on the visual representation, you can do that, but you don't have to. So it's a thing on its own. And this is a little bit more about how this is done in Racket. So there is a Big Bang function that starts the world, and this is all a big macro where various things are defined. So in this example, we have a bunch of dots, and this is a clickable area. And if you click in a position that has a dot already, the dot will disappear. If there is no dot there, it will appear. So a very simple example, one of the first ones that we do with this sort of thing in the Racket class. So the world state here is a list of positions of the dots, the centers of the dots, starts off empty. There is a function that's called on a draw event. So when we need to draw, that takes that world state and creates the image that you see. Nothing is happening on tick because nothing is on the clock tick because the world is not changing on the clock tick. And then on a mouse click, we add or remove a dot. So let me show you a little bit more about how this works in Racket. So the top thing there is a dot, which is a first-class shape. It's just a dot, not attached to any particular position. And then when we need to convert the list of positions to an image, that's display dot that's going from the model to the view. Then if this list is empty, that's an empty scene, so a blank square. Otherwise, we place an image of a dot at the position x and y in that list of positions, in the first element of the list of positions, and then make a recursive call on the rest. So very convenient, very nice example of recursion. And then there is a similar function that deals with adding or removing dots, takes a list of positions, coordinates of a click, and returns a new list of positions. And I'm not showing the code, but I'm sure you can all write something like this. OK, and now I'll turn it over to Ryan.
So when we were looking at implementing first-class shapes, we needed the model view controller, and luckily Quil existed, a nice graphical library, along with functional mode called fun mode made by Nikita Beloglazov, which was already implemented the model view controller for us. So we had that there. The state is basically a hash map that you can alter using multiple functions, or you can individually change everything using functions, or you can associate and change. And fun mode plus first-class shapes, we made a joke and started calling it super fun mode. So that's what, yeah. So ours is just implementing first-class shapes into the functional mode of Quil. And so the elements of the state are modified through functions. This is just an example that we were using to learn Clojure this summer. I had actually never looked at it until this summer. And this is an example from the summer that we won't go in depth into at all. So here's the update state where you change individual things on clock ticks, basically, and then there's functions like update speed and update rocks that would change each one as the clock ticks happen.
So, shapes as first-class objects. We are looking
to sort of implement this in the Racket style that Elena was talking about earlier, in that shapes are treated like objects and can be modified through functions. Shapes as objects would hold their specifications for drawing them on the canvas. And this sort of makes it easy to redraw and reuse shapes once you've already sort of initialized the shape. And sort of having this shape object seems easier for beginning people and beginning students to understand, at least conceptually, to have this thing that you can sort of, it's almost like a shape object, which it is. So like we say, functional Quil sort of uses the paintbrush approach, where when you create an object, it's sort of the by pixel location, in that you can't visualize an object off of its canvas. It is where you draw it on the canvas, more like, a paintbrush, versus our first class shapes, which is more the collage approach. So in this picture here, you see we've got the sort of pieces by themselves initialized, and then you can modify those and think about them more abstractly before applying them to the canvas.
So how Quil deals with simple shapes is the shape lives entirely in the draw function. There isn't actually an object. So if it doesn't, so in this example, we draw a background, set the fill color to green in this case, and then we use the Quil function to draw a rectangle at position 300, 300, with a width of 100 and the height of 200. So you can't actually, make that same rectangle unless you keep the fill the same color and, change the XY coordinates. So our function, instead, you define it once in the setup and you can reuse it whenever you need it. So in this case, we create a rectangle of width, height 100, 200, and we set it to green. And that green is actually just colors that we predetermined. So beginners don't have to worry about RGB values. They can use green or blue, and they don't have to worry about it. And then we draw, we call our DS function, which stands for draw shape, at position 300, 300 instead. And you can draw it at whatever position you want repeatedly.
So sort of taking this idea of simple shapes one step further, we have something called complex shapes, which are essentially just collections of simple shapes in the abstract form. So when you create a complex shape, it's your simple shapes offset from a center position, and each simple shape holds its individual offset from that position. And in our first class shapes, we've implemented functions that we found in Racket, like the example earlier, above, beside, that sort of thing. So in this example here, we have our green circle and our green rectangle, and you can create a complex shape called object, and then beside them, and then you can draw the complex shape at your position, and it will draw both of these simple shapes as one complex shape on that position. So here's some examples of above and beside. In this code block, you can see we're creating green scale rects with above, and you pass in the arguments sort of like the image would suggest. So when you're aboving something, you quite literally put the names of the simple shapes above each other in the order that you would like them aboved. And you can also call reduce on above and apply that over a vector pretty easily, and it would produce the exact same results were you to just call above on the same thing. And now for a successful live demo. So here is something we were just, pretty simple thing we were working with earlier in the summer. So this is two complex shapes overlaid, sort of stacked on top of each other in the draw state, moving in a sinusoidal pattern across each other. And this entire demonstration is actually just created out of two simple shapes on top of each other, a box and a line, and then those are made into a row with beside, and then those rows are above on top of each other. So this is created with above, beside, and two simple shapes, and you get this entire sort of cool rotating pattern thing that you just stare at for a long time and get back to your presentation. Yep, and then when you, again, Quil has like easy mouse implementation things so that you can switch orientation. So switching from the boxes moving horizontal to moving vertically. When we jump to the code, you can see just how easy that is, because you are moving the entire complex shapes and you don't have to worry about pinpoint locations like you would in normal functional Quil. So in here, we're defining our line length, our box length. We create our simple shape diagonal line here with the create line function. And then we have our sort of invisible block underneath it, which is just the outline of the block it's on top of. And then we create our first complex shape called block line using above of our two simple shapes. This demonstration does sort of scale to fit screens, so we're checking total width and total height. And here's our first row creation. We're creating our complex shape row using reduce beside and repeating with our simple complex shape until we fill our screen to create our row. And then we follow that same pattern until we filled our width and height of our screen here using reduce above. Here we're just checking the mouse to see if you've clicked if we want it to move horizontally or vertically. The update state function, which is just changing the angles so that we have that nice sinusoidal pattern. And then our two sort of helper functions for our draw, which have some nice let blocks, but essentially boil down to just drawing those two complex shapes very easily, really. And finally, in the draw function, we create our background, we fill the line color, and then we just see if we would like to draw it horizontally or vertically. And that's really all there is to it.
So if we are going to combine multiple complex shapes together, it creates a new complex shape. So in this case, we have a complex green, which is made up of a circle and a rectangle, and a complex blue, which is also made up of a circle and a rectangle. And we combine them together to create the complex shape that consists of a circle, rectangle, a circle, and a rectangle. Overlay is another function we made, which also creates complex shapes. In this case, we decided to make overlay where the first argument is at the front of the image, and the last argument is at the back, or top and bottom. And in this case, we're just overlaying different size rectangles on top of each other. We also have an align version of each function. Above and beside take in one argument along with the either complex shape or multiple simple shapes, and those are left, center, and right. And if you were to above align center, it's the same thing as above. And basically it offsets it, in this case, to the right. So you have like a tower leaning to the right. And overlay align takes two arguments before the thing, which are top, center, bottom, or left, center, right. And that will, in this case, we did bottom right and overlaid them on the bottom right of the entire complex shape. We can also rotate and scale. So in this case, we are rotating a red square of some size, 45 degrees. And you can also scale, and it's actually an X scale and a Y scale. So we're scaling the X axis and Y axis by 2 in this case, so we're doubling the size of the shape. And then you can apply it, you can first scale it and then rotate it at the same time.
So Quil's functional mode it does deal with images, but it does it in sort of a convoluted way that took us quite a while to figure out. So we thought it would be really nice to make it easy for beginning and intro people to understand how to make an image. And we thought, what's really easy? Well, the shapes that we've been making already. So we decided to do images just like our first class shapes, so that you can essentially define a really cool picture and then just create that picture with the file path. And you can apply all the same functions that you can to simple shapes to these images, and you can incorporate them into complex shapes, and they're dealt with just the same way with the sort of bounding box of the image. So in this case, we're creating our cool picture on the left there, and then we're creating a black box, 100 by 50, And then we're aboveing the image, scaled up to double size, and on top of that black box, and it works. So with all of that in mind, we did a sort of simple code comparison here with Quil's normal functional mode on the left side and our code to draw on the right side, and both of them are drawing that shape in the middle there, sort of the circles on top of each other. So if you look at Quil's functional mode, you've got your background, you've got a fill and an ellipse and 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 a fill and an ellipse. And when you're looking at this, it's like, yes, it does make sense that you're filling these colors every single time you would like to create a new ellipse of a different color and a different size, and you have to do those calculations. But just conceptually looking at it, you don't get the idea of this shape. You get a block of numbers that you have to figure out what the RGB values are for and what the positional differences is. So if you were handed this block of Quil code, would you know if the circles are aligning on top of each other or on the bottom of each other? Versus when you look at our block of code, you've got your green ring, your red ring, yellow ring, blue ring, and you can see that they're overlaid top center orientation with green on top, red, yellow, blue, and in this case we're actually reusing the yellow ring scaled up to double size because we can, because it's abstract before it's drawn on top of the canvas.
So with that in mind, what's actually under the hood in each individual shape is what you see here. So this is how you would create a rectangle. You throw in the width, height, and then the colors. And we define what needs to be known. The width and height are the width and height. And then complex width and complex height would be, if that is part of a complex shape, what the complex width and complex height are. In this case, it's just an individual shape. So its complex width and height are what it currently is. dx and dy are the x and y offsets from the origin of the complex shape. So in this case, there's 0 because we're not in a complex shape. Angle is whatever, if you apply rotate to it, angle changes. And then the internal ds function actually is what draws the shape. So that gets passed in x position, y position. If it's a picture, in this case, it's not, so it just gets handed null. We never use it. Then the width and the height, and then current stroke is the outline of the box or the color of a line if you're going to draw it, and angle is how much it's rotated. We first have to check to make sure we have a color, and if not, we set it to no fill. But if we do, Quil actually takes in anywhere from 1 to 4 variables to determine the color, so we have to account for each case. So if you're coming straight from Quil, you can use your colors. From there, we actually draw the rectangle at 0, 0. And then if there's a rotation, we apply the rotate because the way rotate works in Quil is it's based entirely off the top left corner of the canvas, or 0, 0. So after we've rotated the shape, we then translate it down to the x and y positions. So rotations happen, and they don't get slid off the screen when you rotate. And then we set it back down to no fill to make sure we don't mess up any other shapes. Complex shapes are just a vector of simple shapes. So what we just saw in a vector, all those hash maps in a vector. Each shape knows its position from the center, as I talked with dx and dy. And this is different from Racket's implementation because when they create a new complex shape, it's actually just an entirely new image. So you can't pull it apart or pick out anything. And what this allows us to do is alter individual shapes within a complex shape. So we'll look at another demo. So in this case, we have a complex shape consisting of 16 times 16 smaller squares. And you can easily change the size of those squares. And so this is still a complex shape, and when we explode it, you can alter each individual shape, which Racket would not be able to do. So looking at the code for that, we create the shape here by aboving and besiding things. It's called Big Bang. Mouse click to determine whether it's exploding or not, along with the 2 update states for whether it is exploding, and then drawing it whether it is also exploding. And the actual change for our explosion is we're just mapping an associate over each individual shape within the complex shape, and we are changing its offset from the center. And that's all it takes according to the rate and the old dx and dy values, which is why in the example, the center actually moves slower because it's going off of its old dx and dy values.
So that draw shape structure, so whenever you want to take your first class shape object and translate that 2 pixels on the screen, you can call ds, and the function for that is here. So it takes in your shape object and the x and y positions that you would like your shape object to be on the canvas. And then within there, we have to check whether or not you're passing it a complex shape or a simple shape, dictated mainly by whether or not you're handing it a vector. And in the first case, if you are just handing it a simple shape, it goes into that shape and pulls out the drawing function from within that shape, and then hands it the x position and y position you want it on the canvas, whether or not it's a picture, the width of the shape from within the shape object, the height of the shape, the current strokes, and the angle for rotations. And if it is a complex shape that you're handing it, it's essentially the same process mapped over every simple shape within it with the dx and dy translations for the offsets from the entire complex shape.
So in the future, we'd like to be able to get the color of an individual shape. Currently, you can't because the color and the drawing for Quil currently happens within the draw state entirely. So you can't actually get like the state of the color because you just set the fill, you draw the shape, and as soon as you change the fill, that information's gone. We'd like to add more functionality to our super fun mode. Like we said, add the ability to get the color of a simple shape. Rotating complex objects we currently can't do. Ran out of time mainly, but it was also harder than we thought it'd be because of the rotation on the origin. So we're looking to get that working. We want a pixel detail overlay so you can specify exactly how much of an overlay you want instead of just the 9 positions we currently have, like top right or top left. We want to make text be an object instead of how shapes are in Quil. Text is also the same way. It lives entirely inside the draw function, so you can't reuse text. So we want to create a text object so we can reuse it. We want to have more seamless integration with Quil Fun Mode. One of the main things is for pictures, if you want to create a picture, you have to do it within one of the sketch functions. You can't kind of define it outside of any of that, and if you do, it blows up and gives you bad error messages. So if you want to create a picture, you have to do it within the either setup or the update state, and we would like to figure out a way to get around that. We'd also like to add some of the examples we worked on this summer to our Git repo, which I don't think would be too bad to inspire people to work on things or see what we've done. And then we'd also like to integrate a music library into it so you can have images and music, possibly overtone we've looked at.
So if you guys want it, you can absolutely get everything that we've done so far. We've got a Clojure page, so you can pull it down from there, the link's there. We also have a GitHub page with all of our materials, as well as other things under the Clojure intro course, sort of the entire working into building this into the introductory course and other things in that line.
Related and similar work, completely independent from us, but also similar is Tom Hall did a talk at Clojure. He used GeoMLab, which was similar with the above and beside and stuff, which was kind of interesting because his was also for educational purposes with first-class shapes, which apparently it's a common idea, so we thought that was cool. And prior work, old UMM students actually came up with the ideas for what we currently worked on, so Max Magnuson and Paul Schleep. And yeah.
We also like to thank HHMI, the Howard Hughes Medical Institute, because they they funded the entire science department really at Morris. So as CSI, we got a part of that grant, and that paid for me to do this research over the summer, as well as LSAMP grant that paid for Ryan to do the research over the summer. I also like to thank Clojure Conj and the sponsors and organizers, because otherwise we wouldn't be here up on this stage. Yep. Questions? This is we made the parenthesis with that code there.
Question mark.
Oh, question mark. It's parentheses on the brain.
Okay, so first of all, the objective of a first course is not necessarily to teach people any individual programming language. It's to give them the key concepts that they would be able to build upon later. And the second part of that question, so why, what's the difference between Clojure and Racket, is that correct?
Well,
yeah.
How do you think the result will distinguish itself?
How it would be different. I think one main difference is that Clojure has a lot of opportunities for students to work on their own, immediately transitioning from the class. There are plenty of libraries. One of the things that I've been running into with the Racket class is that students want to do things that maybe even exist in Racket but don't exist in the subset that we're covering, and they're difficult to get even documentation on. So Clojure is much more open in this sense. It's much easier to bring things in. So I think that's a distinguishing part. And another related element of it is all of the open source projects that students can contribute to, many more examples online that actually scale. So I think it just is, to me, it's introducing students to much more open community, for which we're really grateful to everybody here, and yeah, you in particular. Yeah.
And one thing that kind of intrigued me to want to do Clojure instead of Racket is that Racket's not really used in the professional world much, where Clojure is. So knowing that you're learning a language that's actually used to get a job outside of college is reassuring, instead of Racket, which isn't used a lot.
Well, to follow up on that, however, we don't follow that road too far, because there are schools that are forced to use languages that people perceive as professional, and starting with C++ or Java is definitely not a good plan. There is a lot of discussion of what people should start with, but these two languages that have been pushed are not it.
Yeah, I know when I was an undergrad, they were, like, right coming out of it, there was a lot of discussion in the CS department about moving from Python as the introductory language to Racket. And there were a whole bunch of debates about that. So I'm actually curious about, in your time at university, you've seen that it's easier for students to go from imperative to functional, or functional to imperative, and sort of that paradigm shift that is around that.
Okay, and I'll repeat the question. Sorry, I didn't do it with the first question. So the question is, between teaching Python first or Racket first, how do students deal with subsequent classes? How well does it prepare them? And actually, we'll ask Ryan and Thomas, because we have both introductory classes. So Ryan actually went through the Python class. Thomas went through the Racket class. So they can tell you. But from my standpoint, I think one interesting thing that I observed, well, a couple of things. Recursion definitely is much, much simpler as a concept, no matter what language. if you have functional background. And algorithms in particular, anything that's recursive, even if it's pseudocode, is easier to understand if you have good grasp of recursion, which is what you get if you do Racket. And another interesting element of that is callbacks in JavaScript, which we do now in our software design class, so we use JavaScript. Again, that comes actually from some TAs, that feedback, that students who have gone through Racket class understand callbacks much easier. You pass a function, then you call it. What's the big deal? So that's my take on that. And we can hear from Thomas and Ryan.
That's done, I guess. So I went through the Python class, and I actually didn't get introduced to a functional language until this summer when I started learning Clojure. So when I started it, I was actually finding myself trying to use the for loop, which is not a for loop, as I discovered. So that was hard for me to get to grasp. And I mean, I had used recursion, but I leaned towards the for loops mainly. So it was definitely a switch where he came from the functional side of Racket, so I think it was a little easier for him to learn Clojure than for me.
Yeah, so we were looking at Clojure over the summer. So it'd been maybe 2 years since I had looked at functional languages, but just coming back to it, it was like, oh, that's like this, and that's like this, and that's like this, and I understand this. This is all recursion, and we fell into that for loop trap there, but we got out of that pretty quickly. I had a period coming out of starting with Racket and going into Java where I was like, well, okay, we have for loops here, but why don't we just use recursion? Like, why don't we just use recursion with everything? Which, in some cases, you do, but not in Java. So, sure. Yeah.
So I think students transition. There are certain approaches that we use in our Java class with the understanding that a significant number of students came with only functional background. So when I was trying to adjust to that, I started doing a lot of small methods, static methods, as sort of an equivalent of a function, and that worked fine, and then slowly transitioning to a more object-oriented model. So that's one of the adjustments that we made to accommodate students coming out of Racket class. But other than that, we really don't see a whole ton of difference. It's really about concepts. Some things you have to kind of explain twice to both sets of students in data structures. Past data structures, they're good. So.
One of your early examples had a nice symmetry, and I wasn't sure if you were going to show something nice where you allowed to specify something and then say it exhibited such and such a symmetry. And if you haven't, there's a book from John Conway called The Symmetries of Things, where they're completely classified all of the plain symmetries. It might be nice to get that in code. I certainly intend to myself.
Which slide was it?
Very early on when you say that the composite image is this.
This one? Oh, okay.
Yeah.
So that exhibits at least. I was hoping at some point you'd say, we've got this thing, we can express symmetries, blah, blah, blah. Is this a picture?
Yeah. Well, one thing that we didn't find, it doesn't exist in Racket, and it doesn't seem to exist in Quil, is an easy way to do a mirror image of anything. That's different from rotating 180 degrees. And I don't know if there is a primitive for that. What's that?
Yeah. Oh, okay.
Okay.
Something that does mirror if you want that.
Okay. Yeah, certainly would be cool to introduce, because I don't think it exists in Racket. I looked. One group of students was looking at that. So.
I think a neat way of expressing all of them using the notation calculated with dots would be great.
Okay, yeah, that sounds really cool. Yeah, thank you.
You can take it.
Not yet. That was a summer project, and would be nice to do usability study. Would be nice to do usability study on some of the error messages things that we have done that's not related to that. We're getting there. We're a small school, and people get really busy. Summer research is a great opportunity. During the semester, things move much slower. I wish we had, a real lab and all of that, but yeah. But it's definitely on the list. It's definitely something that we would like to get user feedback on.
Is the test spring class happening? Spring class with like Ben? No. Okay.
Okay.
Yeah.
Yeah.
Any other?
Well, thank you.